Okay, we've got the product rule here for dy dx. We're asked to find this in the first instance in the question. Let's just do this first. So it's u. Tan of something goes to sec squared of the something multiplied by the something differentiated. So that's u to v plus v times du, which is this differentiates to 1 lot of. So that's that. So we can just put that up there. Tan x over 2. Okay, so d2y is we're also asked to find. I'm going to move this half over to be here, so we can just differentiate it. And remember, we can write sec squared of x over 2 as that squared, can't we? For the purposes of differentiation. So this is a product, so it's u times the v. This would be 2 times the something to the 1 multiplied by the something differentiated. Sec differentiates to sec tan, and we mentioned that in a preceding question. It's a standard derivative. This is sec x over 2 of the something, isn't it? So it's u squared, 2 lots of u to the 1 multiplied by du dx, and sec of x over 2 differentiates to sec tan, but it's a function of a function multiplied by a half again. So that was u to v plus, so we've done u to v plus v times du, and half of this just goes to half of 1, which is a half, and that's v du, plus, and tan goes to sec of something, sec squared rather, tan differentiates to sec squared of something multiplied by the something differentiated. So that's d2y by dx squared. Okay, now in the problem it tells us that we need to work out 2 cos squared. So we have to get it in terms of cos squared here. Okay, so it now says, now the left hand side is 2 cosine squared x over 2 d2y by dx squared. Yeah, I'm not going to worry about that just yet, but that's where we're heading for. We want to work on that on the given question. So why don't we just tidy this up first and start writing it as cos. So this is x plus, let's get rid of that. It's going to be, oh, that was times. Yeah, there's a lot of stuff going on here. We've got an x plus 1. We've got a sec and a tan. And a tan. And that's a half of, so we'll put over 2 there. That was that term there. So yeah, sec squared tan plus sec squared x over 2 there, but plus that twice, isn't it? Because that's the same as that. A half plus a half is just 1. It looks like to me. So we get that. So I'm going to times that by cos squared now. I'm going to times it by 2 cos squared actually. So 2 cos squared of x over 2 dy dx is equal to, now cos squared times sec squared will cancel each other out because sec squared is 1 over cos squared. And the 2 will cancel here on this first term. So we'll be just left with the x plus 1 times tan x over 2. And the second term, the sec squared will cancel with the cos squared when you times it by it here. So that's d2y by dx squared, isn't it? So I'm timesing this by 2 cos squared here. So I'm timesing this by 2 cos squared, and also by this by 2 cos squared. So you get plus 2. Now, what do we need to show? Y plus 2. So hopefully, x plus 1 tan x over 2 is that. Yeah, there it is there. That's y. So that's equal to y plus 2. Yeah, that's it. That's what we wanted to show. Do 2y by dx squared is equal to that. Okay, that's good.